Yeah, so DAG versioning, we heard about it a little bit during the keynotes this morning, but we're gonna definitely dig in more here. So yeah, thanks for coming. Really quick about me, I work at Astronomer. I'm a committer and PMC member as well. Yeah, Vikram kind of stole my thunder with this one, but DAG versioning has been the top feature that people have asked for in the survey since 2020. The thing is that when you ask what DAG versioning means, you get different answers. And we'll kind of dig into like what those are over time. But let's first take a look at like why versioning matters in the first place. So let's imagine that we have this Airflow DAG. Very simple, one task, nothing noteworthy, and we have a few runs. Now let's go ahead and add another task to it. Okay, easy enough. We get some runs, the grid looks good, as we'd expect. But the story gets a little more interesting when we go look at the graph view. So if we look at the graph view for those first 3 runs, we have the world task in there, but it wasn't there when it ran. So that's not great. So then what happens if we go back in and remove the world task and go back to a single task? We go look at the grid and, world's gone. And then if you notice, we didn't actually have any run, right? The 3 that had world initially is just missing it, and no new run. Airflow parsed it, and it just dropped that task completely from view. And then you see the same thing in the graph, right? You go look at the graph for the 3 runs that had world, and world is no longer there. So you're losing that information. What happens if we go in and we just replace all the tasks with a different task? I imagine you can figure out what it'll do. You lose hello world completely. You have no context as to what happened in those runs. So that's clearly not ideal. So what with features today can we do about this? One strategy is that you can version your DAG ID, and this works, right? Like if you're like diligent about bumping those versions as you make changes, the grid view and the graph view will be accurate. The problem is you fragment your history across multiple DAGs, and it becomes very tedious to try to like figure out where the run that you're looking for is. So that's not great. What if we use end date? I mean, this can work pretty well. Setting these can be a little bit tedious, especially in not DAGs that are longer than this. And so yeah, and it also doesn't really work well if you're doing like a lot of structural changes in your DAGs. So the grid view, though, does handle it a lot better. So that's a positive. But the graph view is still not great. Yeah, like graph view is not usable. So let's talk about another scenario right here. Here we have a task that uses 2 retries. And it's written in such a way that it'll always fail the first 2 tries and succeed on the 3rd try. And if we go run that and look at the Gantt chart, we see no failures. We see this big gap, right? Did it succeed the first time and it just didn't run for however long that is? Did it take 1 retry, 2 retries? Now, of course, we set this up so we know exactly what it should show here, but if you're just coming in, you don't know what actually happened for that task, right? And so yeah, that's like these are some of the scenarios that kind of fall down in the current UI. If we go look in the database, the task instance table, you'll see that we literally have 1 record in there. Try 3, success, state. Those first 2 tries aren't there anymore. And this really, I think, is a good thing to hammer home, is that when we start talking about like retries and clears, the only thing that is consistent across all the tries is the primary key of the task instance. Everything else can change. What the operator was even, which if you haven't done that experiment, it's a fun one, I recommend it. But yeah, the only thing that is consistent is the key. So if you're looking at the latest try and like making assumptions as to what it was earlier, you might be wrong. So what do we do about this? So DAG versioning there's a lot to it. We ended up splitting this into 3 different AIPs, 1 for TI history, 1 for execution, and 1 for UI changes. And we have an umbrella AIP that kind of covers all of them. The umbrella is AIP 63, and the others are 64 through 66. AIP64 covered TI history. The good news is that that's actually in Airflow 2.10, so you can go play with it today. And if we go look at the same, fail twice, succeed on the third try, this is what we see. Hey, that's a lot better, right? So what happens kind of under the hood to make that possible? We ended up creating a new table called TaskInstance history. We keep the latest try in the TaskInstance table still. That was a significantly easier approach just because there's tons of things in Airflow that deal with TaskInstance. So having the latest try there just made compatibility a lot easier. What we do then is anytime we go to bump the try number, say we go from 1 to 2 because it failed, we just take a copy of what that TaskInstance row was and move it into the history table. And that's now our stamped history record. And it's a perfect place for us to kind of store that over time. So if we go look in the database now, if we ran the previous query, right, where we do TaskInstance, you would still see the one try. But you can now look at the TaskInstance history table, and you have the 2 failures. And I'm just querying those 2 columns, but the rest of them are there, start date, duration, et cetera. Cool. Well, you probably don't want to be directly querying the database, but there are API endpoints that you can use as an end user to get at this information. So yeah, the URL is a little big, but the key part is it's your normal TaskInstance URL format with the tries on the end there. And that will actually combine the records from those 2 tables and give you an accurate representation of the tries that TaskInstance has had. If you only want one, though, we also have an endpoint for you for that, too. OK, so next I want to talk about the execution changes we're going to do. Fair warning on this one. This is being worked on currently. I actually have a bunch of changes locally on my laptop. And so, yeah, this is very much a work in progress. We're broadly going to kind of introduce a couple things here. We're going to have DAG bundles, and Caxel kind of alluded to that this morning. We'll talk a little bit more about those here in a minute. And then we're also going to have some parsing changes that come into play. So first, I want to let's talk about, this is a really high-level goal, and maybe the most important of this whole AIP. We want to make it possible for you to run your task on a specific version of DAG code. So that means that we want to make it possible for the scheduler to say, we'll use Git as an example. I want all of the tasks in my DAG to run on this commit hash through the whole chain. We need to make that possible. That means that the scheduler has to be able to, figure out what the version should be, send that to the worker. The worker has to be able to actually go out and get that version of the code. That also means that you have to be able to have more than one version of the DAG code on the worker, right? Because you could have DAG runs on different versions at the same time running in Celery Worker, for example. Another high-level goal on the execution side is being able to get DAGs from many sources. Basically, we didn't want to force everyone to version everything in their Airflow deployment together. Being a little more flexible, being able to do it for things that are related, being able to do it for your team alone, we thought that was a kind of an important boundary to set. So yeah, no more single local directory for DAGs if you don't want it. It is, we'll get into it a little more. You can still do it that way if you want, but you have the flexibility now to be more granular if you'd like. So what is a DAG bundle? I like to think of it this way. It's a collection of DAGs and other files. Imagine you take your DAG folder today and you make a zip of it, right? That could be a bundle. Why is it important to have other files involved? You end up having DAGs. It's a pretty common pattern to use YAML or JSON in the construction of your DAG. And so having those versioned together makes it possible for it to be consistent, right? You don't want to have differing versions of your DAG code versus your YAML. That could blow up and make you unhappy. Cool. So we have the concept of the bundle. Now we have the DAG bundle backend. These are going to be, there's an interface for it, and there will be implementations of it that make it possible to use Git or blob storage or whatever you want, really. But the important thing from a core Airflow perspective is that we're going to have an interface Anybody can write a new bundle backend, configure it to be used, right? That makes Airflow's job easy. It just uses the bundle backend, and the complexities of whatever it is can kind of live there. It also gives us flexibility, you know? Let's say in a few years a new technology takes off and we want to integrate with it, you can just write a new bundle backend. So let's talk about some of the design considerations when we're trying to figure out like what these backends should be able to do. This may be a little interesting. Versioning should be optional. I just talked about versioning a whole lot, and now I'm saying that you may not want to do it. I think the easiest use case to think of is keeping support for a local directory, the equivalent of today's DAG directory. I don't want to have to version my local DAG directory every time I make a change, so I figure you all may not want to either. There may also be some technologies that don't have like easy native support for versioning, so making it optional is, I think, is a good thing. It makes it flexible. Okay, there's a lot to this bullet point. We also have to consider the way, like the places in Airflow that are going to use bundle backends and how they may differ. So for example, Kubernetes executor is probably going to be the shortest lived piece of Airflow. It's going to go out, get the DAG bundle, use it for that one task, and then probably throw it away, right? If you contrast that with the scheduler, it's probably going to have a DAG bundle that's going to try to keep up to date, right? It's going to have a more persistent copy of it that it just kind of keeps up to date. And so, yeah, we have to design the interface in such a way that we can kind of tolerate those different use cases and the different needs that they have. And then I put temp in quotes here. Really, we need disk of some sort to actually put these things on. And so this will be something that the deployment manager can configure, and you can use storage that is appropriate for your environment. So let's talk about, well, I guess I should say, Git is one of the DAG bundle backends that I'm planning to write. I think it's a really it's fairly straightforward to write, and it's an obvious example when you think about versioning files together. And so the nice thing about this is, versioning is built in. There's really good understanding among all of us about like branching and tags. And so what this will let us do is we can write it in such a way that you can either point it at a branch, you can point it at a tag, and it'll kind of do the right thing. I mentioned this earlier, so I'm also going to build a local backend that doesn't support versioning, and it's also going to be the default. So when you spin up a new Airflow 3 instance, the idea is that by default you'll get the local backend pointing at the DAG directory. That keeps backwards compatibility and doesn't have any breaking changes for people that are upgrading. But folks are always able to opt in and use different backends and completely drop support for a local DAG folder if that fits their use case better. Okay, there's a lot for this slide too. So blob storage. This is one that I'm not planning to write, but it's always possible for someone in the community to raise their hand and write it. I would be a little surprised if we make it to a release in 3.0 without it, but we'll see. It's not quite as straightforward, though, to implement versioning with blob storage. Typically, blob storage versions at the object level. And remember, we need to version all the files together. And so you have to have some strategy to version them all together, like a zip file or maybe different directories. Like there's many ways that you could do it. But I think the important thing is that whatever strategy the author of the bundle backend chooses, that complexity is hidden in there. Core Airflow doesn't have to consider it, right? Like it can use the same interface that it uses with Git, and it doesn't have to worry about whatever funky stuff you need to do. Now, I could very much imagine a blob DAG bundle backend that does not support versioning also, right? That's also fair game. Cool. So we kind of alluded to this a little bit, but yeah, how we configure DAG bundle backends. All of these will support it. You can do it through the UI, the API, the CLI. I think the API is a really interesting use case because you could have, CI/CD go in and change the tag for your bundle backend, for your Git DAG bundle backend, and point at a new tag. That kind of thing. It's a big departure from today's world where you have the magic DAG directory that Airflow consumes, and it offloads a lot of complexity onto the deployment manager to kind of like deal with that. This is a common one, I think, for a lot of things in Airflow 3. How we package and distribute these is going to kind of depend on what execution interface looks like, how we're going to package that. So the final home of these things is a little bit to be determined. We will figure it out, and it will be easy, I promise. Let's shift gears a little bit and talk about the parsing behavior a bit then. One thing that we're going to add as part of the bundle is, we call it a manifest. It's a YAML file, and I have an example in a minute, but I want to talk about it a little bit before we start reading it on the screen. I like to think of it more of a general place to put metadata about the bundle. It could be at the bundle level. You could even break it down and start doing some metadata about specific files or parts of the bundle. The first use case will be parsing controls, but I think it's going to be a flexible place, and we'll end up seeing kind of like evolution, like other components in Airflow using it. So it'll be interesting to see how this one evolves over time. But yeah, this is the example that I have written in the AIP today. I think that what we'll end up with will be a little different, so don't look too closely. But the rough idea is be able to support things like this, right? This directory, I just want to scan daily instead of every 5 minutes like we do by default. Or, hey, I don't want you to scan this directory at all. I'm going to just tell you what files have DAGs in them. And then it also opens up the ability for us to put things like this. Like this would be a bundle level config of how often should the scheduler go out and see how, like if there's a new version of the bundle. That one may move to the CLI, API, et cetera, but we'll see. And then a little segue, these parsing improvements aren't the only changes that are kind of planned or being discussed for Airflow 3+. Yeah, AIP 85 is a newer AIP that is not going to be in Airflow 3.0, but is coming later. And that's going to take parsing even further. Michael talked about it a little bit in the keynote this morning. But yeah, the short version of that is it's going to offer pluggable parsing. And so you could potentially have a custom parser that is able to generate a DAG directly from a YAML file. Like you don't even need to have the Python intermediary. So this is I think later on in Airflow 3's lifespan, we're going to have some cool parsing features for sure. Cool. UI. So this is covered in AIP 65. It is still a standalone AIP from AIP 38. AIP 38 is if you're not familiar with all the numbers, that's the modern UI, AKA replace everything with React. There's enough in there. We didn't want to add more. So 65 has been kept separate so that we can make sure that the versioning use cases specifically are still covered. But the caution sign here is even more important. I guarantee what I show you here is not what it's going to look like, but try to understand the intent behind like the information that we're trying to show. But I think this is a good time to pause. And if you remember back, I said code version, right? Or we're also going to have the concept of a DAG version. It's a little weird, right? Like why do we have two versions? And we'll look at why right now. So this pattern is something that we see in Airflow, and this is a simplified example, but you can imagine the pattern here. In this case, we're getting the list of tasks we create in the DAG from an Airflow variable. This could be an API call to another system. It could be reading from a separate external database. You name it. This is the reality though in Airflow and a lot of like real world use cases is people are using external things. The DAG code itself is not enough to know what the DAG structure looks like. And what that means is that, hey, if we go in hello world now, what if I go change that variable to hello San Fran? Ta-da, it is now San Fran. I didn't update any DAG code at all. So all of the execution stuff that we talked about, even if I can guarantee that I put the same code on disk for your task to use, I can't guarantee that the DAG is going to look the same, which means all these things that we're going to talk about here in a second are still things that we have to at least tolerate, right? Now, if you do have static DAGs though, then you don't have to deal with the things we're going to talk about because you can guarantee that your DAGs are going to be the same across runs. So there's a little bit of power, or I guess DAG authors are empowered now to kind of choose their destiny here. They can avoid the funkiness that we're going to look at and yeah, have a more sane environment if they choose. Cool. So the code version, I think, is pretty straightforward. What about the DAG version? What is that? This sort of by necessity needs to be observational. And so Airflow needs to look at the DAG that is generated and figure out a way to fingerprint it somehow. The easiest way to do that is to just take the serialized DAG that we already generated. It's a simplified version of the DAG for powering the UI and the scheduler. Take that and hash it. Right? That's a low bar that's easy for us to hit now. You may go, well, wait a minute, if I make changes in my Python callable or in another file, like that won't change my version. True. But it's also kind of a slippery slope. So we have to find the right balance. We're going to see if we can get a little bit more perceptive of those types of changes, but I'm leery of committing to it, is how I want to say it. But one thing that I will commit to is that we're going to offer a way for people to inject their own version string. And so Airflow will take the observed version and the version that the user provides and combine them. And so this gives users the ability to kind of like, hey, I have a new version. Here's my new bump, right? Like you can force a new version to show up in the UI if you'd like. It also gives authors a way to provide a little information about the version also. Hey, like think about Git, put the tag that you're using in. But Airflow can protect itself also because it'll observe if something changes and you didn't bump your version string, right? And so Airflow is able to avoid the problems we had seen earlier also. This is why the TI history thing was kind of like the first step in this process is that we need to track the DAG version at the try level. So now with that history table, we have a place to actually put that version and keep it around for a long time and not override it, which is nice. The serialized DAG table and the DAG code table will also be versioned. The serialized DAG one hopefully makes sense. It's used to power the grid view and the graph, et cetera. And the DAG code, it seems weird, but the web server doesn't always have access to the DAG files directly. And even if it doesn't read them from disk. So when you go to the code view in the UI, that actually comes out of the database. And so we need to have versioning there as well. So yeah, let's go talk about some of these scenarios. Hopefully none are too surprising. If the DAG changes between DAG runs, this is probably the easiest one to think about. If you look here, we have some nice little carrots. So in this case, the first DAG run ran with hello world. And then between the first run and the second run, we added the welcome task. Now, if you look closely though, we have another caret and welcome's kind of grayed out. What that tells me is that we're tolerating the removal of the task 2, right? Like welcome is no longer there, but we can see that the second run did have it and was there when that DAG run was run. So no more disappearing tasks. If we take it a step further and we change the whole DAG structure, they're still there. That history is not lost. So what happens if we have changes between TIs in the same DAG run? The caret may be a little hard to see, but there is a little caret in that green box where my cursor is, I promise. If we know that we had a change between the task and any of its upstreams, we can provide some context, right? Of, hey, this is where in the DAG run the version changed. I guess it's important to mention that the whole, oh, well, no, I take that back. Dynamic DAGs can cause this, for sure. But then another thing that I realized that I forgot to mention earlier is that the whole behavior of having the same DAG code will be optional. So you could opt in to have the same behavior of always using the latest DAG code for DAG runs. So that could be another way you could need this feature. Cool. What about on the graph view? The grid view is nice in that there's no relationships. It's just a list of tasks. And so we can avoid a lot of, well, these problems that we'll look at now. So if there's no structural changes, it's very easy. We can just plop our friendly caret in there and move on with life. If there are structural changes, and imagine we had ABC to ACD, we're not going to try to build you a graph. We're going to give you a little control so you can choose the version that you want to look at, and what we'll do is kind of spit out these, right? So if we imagine the line there is, the first version, and then below it's the second version. Say the first two tasks ran, A and B ran when the first version was there. Well, that's what you'll see. You'll see that C didn't run in this version. And then conversely, when we got to the new version, task A didn't run with the new version, but C and D did. Okay, so what happens if it changes between tries? This one's a little trickier to figure out how to, kind of show in the UI, but ultimately it's kind of going to be variations on that same pattern that we just saw. And the specifics of like what that's going to kind of look like is going to depend on what it looks like in Airflow, like generally speaking, what the task interface looks like in Airflow 3. And then clearing. This is an interesting one. Very much a moving target a bit. And in fact, we may even need to change the whole concept of clearing completely, but we will get there. So I think the easiest one to think about is, what if you want to do the whole run? Do you start with the most recent code? Do you go back to the original code? Do you maybe not even like clear, leave whatever that DAG run was, create a new DAG run with the appropriate metadata so that it operates on the same data, right? We have options. We'll just have to kind of work through what those are, build appropriate warnings, that sort of thing. I mean, there's some scenarios that are pretty clear answers of, if the task doesn't exist in the latest version, then we shouldn't let you run on the latest version with that task, right? You can't clear and run on the latest. But yeah, this is a bit of a, we're going to have to figure that one out on the fly a little bit. And yeah, that is all I had. If you haven't read the AIPs, this QR code will take you to the umbrella AIP, and there are links in there for 64, 65, and 66 as well.